It says factoring is the process of finding all of the prime. What does prime mean? Yeah, it doesn't divide out any further except for itself and the number 1. Okay, so it's prime quantities that multiply together to equal the given expression. So for example, let's make a quick factor tree of 100. What times what is 100?
10.
10 and 10, that works. There's more than one way.
5 times 20.
5 times 20. Oh, yeah. I thought you were breaking apart the tens. Okay, what times what is 10? 5 and 2.
Yeah.
And then 10 is
2 and 5.
2 and 5.
Yeah. She's 5 and 2.
Now, kind of like the way we simplify square roots using dates to prom, these are all called the prime factors. Any number at the end of a root. So what do you think would happen if I put 5 times 2 times 2 times 5 in the calculator?
It would equal 100.
Yes. You would get
5 times 2 times 2 times 5 equals 100. So that is called the prime factorization. Those are the prime numbers that multiply to give us the 100 in this case.
Yeah.
Now, sometimes in math, we use parentheses to show factors. So could we also write it like this?
Yes.
Yeah, remember, parentheses bumped up next to each other, that means multiplied. So what we do in this class is usually polynomial factors, so you'll see them in parentheses. That's why we use those parentheses. Okay, it says some polynomials will not factor, just like the number 7. Does 7 break apart except for 7 and 1? No, so we call the number 7 prime. So sometimes things won't break apart, they won't factor. Okay, so let's take a look. A couple of these are going to be reviewed today. A couple of them are going to be totally new. The first thing we learned about is greatest common factor. So when I look at this polynomial, how many terms are there?
2x.
3 terms. What do all 3 of those terms have in common?
2xy.
What can divide out of all 3 of them?
2xy.
They all are divisible by 2. And notice it's the greatest common factor. It has to be the largest number that divides out of all 3 of them. So it's 2. And then do all of them have an x?
Yes.
Do all of them have an x squared?
No.
No. So the largest number of x's that I can divide away would be x. And then what's the most number of y's that all 3 of them have?
Y.
Just one y. That's called the GCF. And then we write a parenthesis. We're factoring out the GCF. And now we go through and just divide away that from all 3 terms. So if I started with a 6, but I unmultiplied out a 2,
Only 3.
we have a 3 left. I had an x squared, but one of them came out front. And I had a y squared, and one of them came out front. So that's 3xy. Minus
Y.
2, but I divided away a 2.
Right.
An x, but I divided away an x. And a y squared, I divided away one y. So out of all of that, the only thing that's left is a y.
Nice.
And then plus 6 divided by 2 is 3. I had x cubed, but I divided away one of them. And that y also got taken out. So that is your answer. Do number 2 on your own.
It's on 30.
Do they all divide by 2?
No.
Do they all divide by 3?
No.
Do they all have an x?
No.
Do they all have a y?
No.
Do they all have a z?
No.
What word do we use to describe something that doesn't divide except for 1 in itself?
No solution.
Prime. It's a prime polynomial. Just like the number 7, it doesn't divide. Nothing divides away.
This situation is we group like terms together. In this case, we can group our first term 28xy with 35x because both can factor out as 7x. 7x goes into 28xy 4y times. 7x goes into 35x 5 times. In the remaining group of terms, 20y and positive 25, we can factor out a 5. 5 goes into 20y 4y times. 5 goes into 25 5 times. We have a 4y plus 5 and a 4y plus 5 in parentheses, so we can factor 4y plus 5 out. We are then left with a 7x and a positive 5. So our answer is
4y plus 5 times 7x plus 5. Oh yeah, super chill.
Polynomials by grouping, a la Schmuck. Grunkle, Gobblerville's newest architect, is having trouble constructing a hovel. His hovel looks like this. If he doesn't finish it by sundown, he will look like this. Can you help Grunkle simplify his blueprints?
No.
The area of the hovel floor should be x squared plus 3x plus 2x plus 6. All those polynomials are making Grunkle rather blue, which is unfortunate since Grunkle is usually a lovely emerald green. Good thing we can factor this polynomial by grouping. The first two terms have a common factor of x, and the last two terms have a common factor of 2. We can rewrite the polynomial as x times x plus 3
GCF is all we're doing here.
2 times x plus 3. See another factor we can pull out? Since both terms have x plus 3 as a factor, we can pull out an x plus 3 from each.
So it's like a GCF of a GCF.
X plus 2 times x plus 3. Happy factorization, Grunkle. All you have to do now is look at your blueprint to see what x is. And x equals the length of a ferocious jungle Jabberwocky. Sorry, you're on your own.
We're basically just going to ignore the second half for a second. So don't scratch it out, but just totally ignore that for a second. We're going to basically treat it as two separate problems. So what is the GCF of the first two terms?
X squared.
Yeah, they both have an x squared. All right, what's left behind? X minus 4. X squared times x minus 4. Good. Now we're gonna ignore the first half. What is the GCF of the second two terms?
3.
3. So we'll put a plus 3 because it's a polynomial. There's a plus sign. And if you take a 3 away from 3x minus 12, what's left?
X minus 4. Yeah.
If you do this correctly, there will always be the same thing in both of those terms. So now, let me ask you this. How many terms are there?
4. 2.
How many terms are now in this problem? Remember, is a term that is anything separated by a plus or a minus sign.
3. 6.
It's kind of a trick question in a way. We have one chunk of stuff that's multiplied together, plus another chunk of stuff that's multiplied together. So how many terms are there?
2.
There's two big terms. And what do both of those two terms have in common?
X minus 4.
X minus 4. So we can actually GCF the GCF. Both of these terms have an x minus 4. So I'm going to factor the x minus 4 out front. Just like we did here a second ago in the green. They both had an x squared, so we brought it out front, right? These both had a 3, so we brought it out front. Now both of these gigantic chunks have an x minus 4, so we bring it out front. And if I take these away, what's left in between?
X squared plus 3.
X squared plus 3.
Yeah.
And now we'll talk more about x squared plus 3 in a second. That is actually prime. We'll find out why. But that is your answer. Try to do example 4 on your own. Follow the same steps. So we have an x squared that I'll factor out, and that leaves behind an x plus 5. What's the GCF of the second half?
-2.
Yeah, they are both negative. So I can factor out a -2. So we'll put a -2 in the middle. And then we put a parenthesis. Now, what is -2 divided by -2?
X.
Positive 1x. Now the part that people usually mess up, I had a negative 10, but you divide out a negative 2 plus 5. We know these have to be the same, so it can't be a minus 5. So this and this move to the front as 1, because it's a GCF. They both had it in common. And what's left behind?
And an X squared.
X squared minus 2. That's your answer. Here are the answers. So factoring 4 terms was totally new to us. Factoring by grouping was new. Factoring 3 terms is not new at all. This is a total 100% review right now. So number 5, if you look at your flow chart, how do we factor something with 3 terms? It tells you to use the bottoms up method. So that's why you have that in front of you. So the first step is always GCF. Do we have a GCF of 5, 13, and 6? No. So we go straight into A times C. So what is 5 times 6? 30. And what are the factors?
Negative.
Well, let me ask you this first. What's the only way to multiply and get a positive number, but add and get a negative 13?
2 negatives.
2 negatives. So what times what is 30? And those same 2 numbers add up to negative 13. Negative 10
And 3.
and negative 3. So in our factors, we say x minus 10, x minus 3. But I know I'm not done yet, because if I foiled that out right now, what's x times x?
Squared.
Does that take me back to 5x squared?
No.
No, we're missing something somewhere. So what's the next step of bottoms up?
Bottom.
The whole bottoms up part of bottoms up. So we always have to divide by a, which is 5. So what is 10 divided by 5?
-2.
And what happens if 3/5 doesn't reduce?
It does.
Bottoms up. So that's 5x minus 3. That is your answer.
So the factoring is
We don't. This is not solving. You don't have to set them equal to 0. We're just factoring. Okay, number 6. Number 6. What's the GCF of 6, 4, and 10? 2. You have to do that, or this doesn't come out right. So factor out a 2. That leaves behind 3x squared minus 2x minus 5. Now, what's gonna happen with that 2? It's just gonna chill the rest of the problem. Your final answer is gonna have a 2 in front. But now we have to do a bottoms up with what's left inside. So what is A times C? What factors of negative 15 add up to negative 2?
Negative 5, 3.
Negative 5 plus 3. Now, I really suggest writing the 2 every time you're going to forget about it. So write the 2, and then x minus 5, x plus 3. Am I done?
No, bottoms up.
No, you need to divide by A. What is A? A is not 2. 2 is the GCF.
6.
The A that we used in A times C was 3. A is 3. A is 3.
Yeah.
So we divide by 3, divide by 3. 5/3 doesn't reduce, so we go bottoms up is 3x minus 5. 3 divided by 3 is 1. That GCF has to be in the front. Otherwise, if you FOIL it all back out, you're not going to get back to the 6. And then 7 is a special case. It's a difference or a perfect square trinomial. You factor it the exact same way. What's a shorter way of writing x plus 5 times x plus 5?
Square.
It's just a